Is this a reduction furnace?
Yeah.
12 kilograms.
Yeah, 12 kilograms.
200 millimeter electrodes.
Yeah.
So yes, okay. Then next transformation point.
카파 아니잖아.
We have in Germany we have
튜브.
a copper plant. Aurubis is called. They use also reduction furnaces. But I never have got an invitation from that. I see only in the newspaper now. This is a reduction furnace, yes?
Yes.
Yeah. 블레이드 튜브. 30mm 두께가.
예, 그때부터 그대로 입원했습니다. 그리고 다른 게 이거 원래 2개 썼었는데 그중에서 SF 중에서 거기서는 2개 썼는데 여기서는 이게 구현이 안 돼가지고 하나는 구현이 안 돼서
2개 했는데?
2개 안 되는데
Okay.
Now number 2, phase 2 is 카파 박스이기 때문에 그렇지 튜브는 또 틀리잖아. You can use the booth, some plate, no box on booth. You can use the phase 1 and phase B and 3. PC is booth, plate booth. So same like this. So in our structure, constructor want to phase B is double booth.
A double booth?
Yeah.
And this?
Yeah. In this case, we cannot insert.
A double copper-plated bus.
Yeah.
Why do you need that?
No, we connected transformer and arm cables. It's different position. And
can you show the total system? The picture of the total system? You want to take here 2 copper-plated
copper booths.
Copper booths.
That no, just tube. Tube is okay.
There are 2 tubes.
Yeah, 2 tube. 2 cable, flexible cable, and previous side of the.
And you want to use 2 copper-plated things. Oh. And you want to get an answer to your question from me. There's no answer outside. You want to have this?
Tube and copper box and
Instead of this.
Yeah.
One? Or two?
A and C is 1.
It's one.
B is 2.
That would have a look. Water cooled? No.
No, cool.
It's
Air cool.
Now let's try to find a solution. Maybe make a new deal. Yeah.
이게 그거지. So you understand this structure?
Yeah.
This is plate.
This flap.
Yeah, plate.
Yeah.
Plate. This is what called cable.
Yeah.
So what called cable, and two
Here.
boost tube.
Yeah.
Tube. Same.
Yeah. I
Water.
understand.
Yeah.
I understand.
But in our programs, this plate, you can adapt this plate in only
May I have
one.
a look onto the electrode, onto the transformer connection?
Yeah, that's
Yeah,
right.
may I have a look at it? Transformer connection?
Transformer connection.
Yeah, what is,
We are two booths.
Yeah.
그러면
Yes,
사이즈를 늘리면 안 되나?
I have a solution for you. Please go to the middle phase, B,
Yeah.
and change cover box. Change cover box. No? No? Cover box completed.
Yes.
Yeah.
Just.
Yeah. There never was this. And please go to the electrode arm. Yeah, and try to change this. There. You see? There are two pieces. You see?
커버 박스 하나 더 있나 그것도?
하나짜리는 없어요.
There.
Yeah.
This is a cover box. Half plated, but we calculate that the current is only flowing in this part of 50 millimeter. You see that?
Yeah.
And this is a solution for you. Yeah? This may be a solution for you. And I do not know what we can do on this side and this side. I make some. This did not happen before for steel making plants.
Yeah.
You understand, yeah? But for the middle phase, you can do that and make this smaller, this distance smaller. Yeah? Then you can use this, but I think you can use full-plated steel, make a full-plated, yeah, 4 tubes. This and the other two. and make this distance very small. Instead of 150, you make 50. Here, 15. And there, 15 there.
Yeah. But this.
No, make a full plated. Yeah? And make this distance 50 or 20 millimeter.
그걸 줄이는 거지 뭐.
예, 그렇긴
15니까
한데.
20으로 하면은
예.
두께가
근데-
15고
예.
폭이 20이면 안 되나?
And also
폭이
there.
30이어야 되지. 저렇게 만들면 두께 되겠다.
예, 근데 but this okay.
Also,
알았어.
this with 20 and this and there's one. Yes.
Yeah.
Yeah. Okay. Make this two.
Yes. But this model is not we can see this part. Okay, no. This transformer in the transformer connection
Yeah.
we cannot see the copper box half.
Plane. We do
자,
not.
원유.
Just now.
Yeah. This and make this small.
Okay, just this
아니,
is
이거
possible.
And this also small.
20이면 그냥 30으로 하면 안 되나? 두께 30에
Yeah.
19S가
I think-
30이니까
I think 20 millimeters. Thickness 30 millimeters.
30 millimeters.
Yeah. Then you have this. But the influence of this little
Yeah.
size
Yeah.
is small. You can neglect this. You can. I would make this construction. But if you need some help, if you have special designs, I will look into my book. Okay, thank you.
저게 왜 두 개 맞나?
다 두 개씩 아닐까? A, B, C 상이 다 두 개고.
아니 봐봐.
Make these. You may have a look at this.
두 개네.
예, 다 두 개씩 해서.
근데
예, 이거 그래서 요거는 우선 두 개를 해야 되니까 요거 신경 안 쓰고 요 두께 자체를 그 플레이트 두께로 적용을 시켰고요. 그때 이게 요 두께가 30 아니니까 그때 이거를 이렇게 적용시킨 거거든요.
See,
요 폭을
these are my handwritten papers. The first is from 1971. This is about the six-phase delta star connection. This were my first attempts. And I have a little answer to your question. I must find the right page. I would choose this solution. Yeah, here. I have compared the MGA with the cylinder and rectangular system. And I try to compare this with this. And the solution is you can compare it with the same length on the surface, Umfang, we say this is, and we can compare it with the same area.
Yeah.
And the best result is if you compare this with the same area. And you find that this and this, if it has the same area, is only the difference is only 2%.
2%.
Yeah? This may help you for your construction. it's there are. This is related very much.
Yeah.
You can go from this step to this step if you calculate the same area. This is a full.
What is higher?
XEE. This is smaller than this. This is higher. XEE is there. Yeah. This is a little bit higher, 2% higher. Yeah.
The same length?
Yeah. It's the same area.
Same area?
Yeah, the same area. This and this bit is full. Must be full.
Yeah.
There are. You must make some attempts to compare this and this, and perhaps this information may help for you.
튜브는 풀이 없잖아.
Because I never have seen this construction fair for a steel furnace. I can use it. This is small, wide. Well, width.
저렇게 와이드 해갖고 두 개로 적용하면 되겠다. 갭을 생각을 해서
예.
두께를 적용을 해서
그래서
볼까?
그 두께가
두께를
플레이트
우리가
두께를
30mm.
예. 그리고 그냥 그 사이의 거리를 44에서 적용시키는 거예요.
This is our secondary transformer connection.
This is the construction?
Yeah.
Uh-huh.
Two push brake.
This is a transformer connection? 6-phase?
Yeah. Transformer connection.
No, this is 3-phase.
3-phase.
3-phase, yeah.
3-phase.
Did you
A,
make
B,
the
C.
drawing?
No.
It's not from you, yeah? Uh-huh. Oh, it doesn't work. Yeah. These are flexible cables?
No.
No, these
These are the
flexible
flexible cables.
cables.
Ah,
Two
yeah.
this one and this one.
Mhm. Why the distance is so great? What is the reason for?
Distance.
Yeah. I think it is necessary to make a big distance.
So I don't know why this in our subconstructors want to this type.
Are these also graphite electrodes?
Yeah.
Graphite electrodes. And this is the construction we have seen there by Mr. Eon. Yeah?
Yeah, same.
This is the same, yeah? You are building this? No.
No.
There's no idea. This only.
Yeah, we already make the structure and cable and always finished. And now it's not delivered in transformer. So next month we install the transformer and then we will start.
We will start to make it. You get the transformer. Is there in your country a transformer? Transformer manufacturer?
In China.
China. Oh. Do you like to get China products? No. Why not? It's too expensive.
Not expensive.
Cheap.
Cheap and delivery is.
Did the Japanese have the transformer manufacturer?
Japanese transformer manufacturers can use it, but in case of the other case in Korea is only own transformer makers. Yeah, Hyundai and Hyosung. Yeah.
You can save a lot of money with transformer making. But in Germany we have two, ABB and Siemens.
Yeah.
They make transformers. We made some years ago with a group, with this group, lectures in Nuremberg and visited the transformer manufacturing. It was very interesting for me how exact and how clean they are working. I was very interested in it. Now we have 11:15, but we have enough time. We want to make discussion of constructions in the until 12 o'clock.
Yeah.
Yeah. Okay. Is there a solution? You accept this? How we can use the program for your special design? Yeah. Try it. Try it and make this in this design with a small full-plated cover box. And make this distance small. Yeah? And you can see what happens. Why do you need 2 and here 1?
Oh, sorry, I had some mistake in. Or is 2. So 2 loose.
The same.
Yeah, same.
Oh, make a small rectangular tube and make this distance small. No problem. I think you can neglect this part. This is not very important. Okay.
저렇게 해서 줄여서 만들어서 넣으면 되겠다. 한번 넣어보라 그러면 수치를.
근데 만약에 이게 폭이 실제 넓으면은 실제로 넓을 경우
실제로 일단
이게 폭을 줄이면은 저거 커버 풀 박스 그냥 풀 플레이트처럼 해가지고 쓰면 문제가 없다고 하지 않습니까? 근데 만약에 이게 진짜 거의 이거랑 똑같은 길이로 폭을 가진다고 설계가
그렇게 지금 안 되잖아.
예, 만약에 그럴 경우에는 어떡하나. 만약에 그렇다면
그러면 뭐가 차이가
그때는 만약에 이게 커지면은 이거에 의한 뮤추얼 인덕턴스 뮤추얼 리액턴스가 커지니까 분명히 리액턴스 값에 영향을 미치지 않겠습니까? 그럼 그때는 이 플레이트를 원으로 바꿔가지고 하는 게 튜브로 튜브로 해서 아예 이렇게 만약에 원튜브하고 단면적이랑 이거 계산해서 이거 두께를 뭐 이렇게 늘리거나 줄여서
그렇게 해도 되겠네.
네, 그렇게 하면 또 될 것 같습니다. 방안으로는 이게 좁으면은 이거를 이용하고 만약에 이게 넓다 싶으면은 튜브 2개 써서 그 플레이트 면적이랑 그런 거 다 고려해가지고 두께랑 해서 하면 될 것 같습니다. 그렇게.
변경을 시킨다 그러면 지금 변경시켜가지고 자 시간이 어차피 12시까지
예. 그리고 이거를 톡만 붙여줍니다. 톡이랑 두께.
센터 바꾸시는데 튜브가 하나 나와서 폭 전체 폭 아웃라인의 폭
예, 플레이트 안에 폭.
안에 폭
예, 중심에서 중심.
요 플레이트 중심에서 플레이트 중심까지
예, 미들 포인트를 좀.
아니 여기서 찍고 요 센터 대중부터는 여기 35인데 여기에 10 두께가 15g에 12네 6 12 47네 여기 10이니까 반 센터가 6이잖아. 여기랑 이쪽이 6이랑 여기서까지 거리가 35. 두께가 10인데 이 시크니스가 튜브 부스
35.
아니 35는 요 사이의 간격.
모르겠습니다.
요 어차피 연결된 부스에 연결된 부분이니까 이것도 저렇게 적용하면 될 것 같아. 12, 12의 간격이 35로 어차피 한쪽은 연결이 돼 있잖아 이렇게.
예.
그러니까 저 기준으로 적용하면 될 것 같은데.
예, 그러면 요거에 35로 두께는 12로 됐습니다.
네.
끝.
그러면 4, 5도 됐고 빠져나가요. 자르고 그 다음에
if you have a reduction furnace, unsymmetry is not so important because the total system is covered. It's covered. There's it's not bad if in one phase there's more power than in the other phase. You can control better, you can adjust much better reduction furnace than a steel furnace. The steel furnace is very difficult to find the right electrode control the working point. But in the reduction furnace, it's always a smooth electric system, very smooth. And the actual reactance is very similar to this you calculated. Very, very similar, very comparable, because there are no big current fluctuations. I think there are also not so many harmonics, and therefore to work with a reduction furnace is much easier than to work with a steel furnace.
Now we postcode and want to reduce the total reactance.
Yeah.
That is in now's aim. Reduce the total reactance. How we can reduce the total reactance?
I didn't understand all. You mean this value?
Yeah.
This?
Yeah.
You want to reduce it?
Yeah. Yeah.
Reduce this value?
Yeah.
Here you must look here. Please, may I have a controlling picture?
Yeah.
Three-dimensional. You can reduce it if you make these distances smaller. The distance is very wide. Try to make it smaller. May you have a look into the top view? Yeah, these distances smaller, if necessary. Make these distances smaller. This would be for me the first step. You see?
Yes.
We have 2 millions and 1.9 millions. I think it's good. But the easiest way would be to change the frequency of your network. There. We have seen you have a lot of examples in your computer. 2 millions, 1.8 million. Yes. Let's see the controlling picture. Yes, better. The distance. But the influence is not very high with the distance. The most important parameter is the length. Can you shorten the length of these cables?
부스 렌스 나오는 거.
Flexible cables. Here, the length to 4,800 millimeters. Make it a little bit smaller. Cable length.
Cable length 4,800.
B 사이드가 크지?
Yeah.
B is also very long.
Very long.
6.
Yeah, 6,000.
Why is B longer than A and C? So for maintenance, it's not good that you have 2 different lengths of cables. This is not good. If there happens something and one cable is gone, you almost have the wrong length.
더 줄여도.
일단 더 줄여야 돼.
그렇게 하면 되나?
일단 그렇게 하면 돼.
Now this has gone smaller.
Yeah.
10% it's a little bit high.
Yeah.
Now this is too small. If you want, yes. The difference is in the flexible cables. There's a little bit difference. And here's a little bit difference. Make in the show the 3-dimensional view. Yeah. A little bit higher here at this point.
Yeah.
Make this a little bit longer. This in the middle phase. Yeah. 100 millimeter longer. Make 2000.
2000?
Yeah. The other two. You see?
Yeah.
Exact symmetrical system. Yeah. This is very good. This is a good design. But it is too much for you, yes?
일단 그 포지션을 한번 가서 얘기를 해봐야 되겠다, 그지?
예.
키우는 거에 대해서는.
Yeah, the length of the graphite electrodes, this does not help too much. And may I have a look on the controlling picture? 3. Did you think to make the system in this way? From here to here?
Yeah.
Direct? It will be shorter. And also from here to here? Directly. If it is enough space in the
Yeah,
plan.
no space.
Is there enough space in the plan? No. No. This is, I think, this is from the transformer. And put the transformer on a higher place that you can shorten this.
Okay.
Huh?
Yeah. More higher. But in upper side there's no space in transformer rooms.
Yeah. And can you choose a transformer? Do you have this picture too?
Yeah. 아까 PDF 떼어놓은 거 있어요. 돌려야 되지 않나?
Where's the transformer?
Yes.
Yeah. Can I have? Yeah, there's a transformer. Yeah.
사람
Yeah.
본다.
Some transformer have a connection on the upper side.
Primary is upper side.
Yeah. The primary.
Primary. Secondary, yeah.
Yeah, it's a primary. Is this a primary connection?
No.
There's a
primary. Yeah, that's right.
Some transformer have the secondary on the top of the transformer.
Yeah.
Then you can. Yeah, you do not need these long connections. Yeah.
Yeah.
You must ask them. Do you have a connection on the roof of the system?
Yeah.
Yeah.
That's right. And now, unfortunately, the transformer is already.
It's already sold.
Yeah.
Is in your house?
Yeah.
It's coming. It's to be manufactured.
Yeah. That's right. And now it's Chinese professor. So.
But if you make another construction, you know.
Yeah. We remember another construction with the
Yeah.
upper side. Yeah.
Okay?
Yeah.
This may be a solution for you. Oh, this is I think this is a very good morning for me. I have fun to discuss with you.
Yes.
And what you have questions, you can get it for me. I forget. Tomorrow I have forgotten this.
아까 그 시트를 다시
예?
You see, you remember this
Yeah.
is too long.
Yes.
This is too long. But now I do not see that there are possibilities to change this. This is physical. But it is small. For 60 cycles per second, this is a small value. If you have had 50 cycles per second, this would be much smaller.
Yes, you're right.
케이블 아까 길이를 지금 현재 포지션이 안 맞지 않나?
예,
다르게
이걸 약간
그대로
낮춰야 돼.
그대로 낮추고 케이블 길이 그대로
케이블 길이
지금
그대로입니다.
케이블도 그대로잖아.
예, 근데
6천
6천이요? 둘 다?
아니
이것만요?
지금 그렇게 들어왔잖아. 하나는
들어온
6천이고
거로, 예.
들어온 거로 맞춰 지금 변경이 안 되니까
예.
줄일 수도 있는데 그건 잘라 할 수 있는데 한번 확인해보고 일단 그렇게 해서 보면 5% 1%가 차이가 많이 나는구나.
다시 한번 바꿔보겠습니다. 그래서 아까 제가 그 뭐지? 아까 거리 못한 부분이 이게 약간 높게 돼 있었습니다. 이거를 높이다 보니까 같이 높아져가지고 그래서 이 부분은 다시 낮춰서 일렉트로드 길이 같게 했고요. 그러니까 이게 또 차이가 발생했습니다.
그래서 지금 현재 그대로 변경한 거지. 그 차이는 별로 차이가 안 나네.
예, 케이블 길이 자체는
지금
지금
바꿨네. 바꿔봐.
케이블 예 지금 이 상태고 6,000으로 할 경우
중간도 좀 올라갔잖아.
예.
빠지나가고 줄어들었네. 일단 저조건이 맞고 약간 높이 조정한 거.
예.
높이 조정했고
예, 그리고
그다음에
폭 조정했습니다.
이거 조정을 좀 해줘야 되겠네, 가서는.
그쵸. 여기.
근데 굳이 뭐 이게 전체 맞추는 게 별로 의미가 없으니까.
네.
이거는 SF는 큰 차이가 없다고 그대로 보는 게 더 좋고.
예, 그쵸. SF. 조건.
그 제일 처음 첫 포인트를 튜브로 하면 어떻게 될까?
컨디션 부분이 일어나서
트랜스포머를 그 튜브로 했을 때
예, 지금 12.
두께만 하면 되잖아.
현재 28. 디아미터 16.
토탈은
약간 적었습니다. 0.04
전체 리액턴스 대비시는 줄이네.
예.
Okay, I have another remark to this. If you have a reduction furnace, in most cases, you have a continuous operation. The material is coming
Yeah.
and the product is flowing out,
Yeah.
continuous.
Yeah.
And therefore, you need not very much lifting in the Z axis, and it's always continuous. And the electrodes are mostly in the same position.
Yeah.
Do you need? My question is, such a big cable length for this. Do you need this? You do not have to think on a steel system, but it may happen that you do not need this big cable length. How you must calculate, I think this is also not shifted because the bottom is standing,
Yeah.
not moved.
Yeah.
And therefore, how much is the cable length you need? And if you can reduce the cable length, here, flexible cables,
Yeah.
you can reduce the reactance. Yeah, that I know. Continuous operation, not much movement of electrodes. Also, they are moved if the electrodes, the consumption is, they have to clamp another electrode from upside. Do they change the electrode, or do they make another system on the furnace? Or did they move the electrodes?
Yeah.
I do not know. But next question. Do you need so long cable length?
In our case, is some different.
Yeah.
We are tricky.
You see, there are also before were strange constructions of current furnace design. I remember that I've seen another construction here. This is in Smedebackens, this is Sweden. The Smedebackens construction. There are very short flexible cables, 2 parts. Yeah? Here and here. And this was constructed in Sweden at the steel plant of Smedebackens, and this is very short. Very, very short. And I also have seen a ladle furnace It was in Bochum many years ago. This was this was constructed. This was the hydraulic system, and the electric system was on the other side. Here was the transformer. And these cables were very, very short, similar to this. You see that? This is the hydraulic system. They have separated the hydraulic and the electrical system. And this was very, very short. This was a ladle furnace. They had many electrode breakages because this was very long, I think 7 meters, and this was very short, and therefore the reactance was small, and the height, the short circuit current was very high, and therefore they had very much forces in it, but they had a short, flexible cable system. You can separate, if it is possible. If we have a look in your picture, you see that this part here was on the other side of the furnace. If you have a reduction furnace, you have enough more space because you do not, it is not necessary to move the total system.
In this case, we cannot use the boost tube, some small boost tube.
A small tube and make the transformer on the other side. If you make a new one. This is the idea you should think about, and you should forget what you have learned with the steel plant system. Make the transformer on the other side. Because with the electrical operation in a reduction furnace, there are no problems. And there can be a very low size of the reactants. It's no problem. This is an idea from me. If you have enough space for the transformer on the other side, you see, this length, you can save this. Okay? Well, if you have the next construction, if this is running, you all would get an invitation from you. Let's look into the furnace. Okay? Now we have a 11:15. Do you have more ideas and more questions? This is important that we are speaking about your construction, not about my construction. Okay? This is some steps forwards, some steps forwards. Forward for you, I also can discuss with you, you know this is on the other side. And you can save this, if you make it. For the steel, it was stainless steel ladle furnace. Stainless steel, yeah. It was they had very much trouble. What we have this morning, Reactance design of existing or new furnace.
Yeah.
We have spoken about two constructions from you, yes?
Yeah.
Okay. I also have a construction made for this discussion for you. May we speak about this, or is it's not so interesting for you? May we speak about my construction, or until midday, or do you have more important? You have more questions to your constructions? Or shall we- This is important, that your construction are important and mine is not so important.
수문사 LF 거도 있잖아.
수분사 LF는 그게 기계도에 확정된 게 아니었습니다. 그래가지고
아니었어도 이제 만들어갈 수 있잖아. 그렇다면 해볼 수 있지 뭐. 지금 만들어진 건데 우려를 이제 보여줄 수가 있으면 이렇게 만드는 게 좋을 것 같다. 그것도 해볼 수 있잖아.
예,
그거 좀
수정 대표
그거 네. We are a new project of LF system.
Adapting?
Yeah, LF rather pony.
Arab. Oh, you are going to Arab.
Yeah.
To Arab, yeah.
그럼 저
수정을 이거 약간 근데 수정을 해야 되는데 이거 컨덴셔 파트
다 해놓은 거 아닐까?
그때 근데 저는 뭐냐 이 부분을 잘못 이해해가지고 전체를 보고 했거든요.
What is it?
일단 보자.
네,
있는
저-
거.
Huh?
야야, you show you the
What kind of furnace is this?
leather ponies.
What? Ladle
Leather
furnace?
ponies. Yeah.
Ladle furnace?
Yeah, leather ponies.
Small?
Small size and 몇 톤이지?
30톤
Oh, what?
30 톤.
30톤
The ton.
Yeah.
What is this?
This is my mistake.
It's your mistake.
Yeah.
I'm glad that also you are making mistakes. Not I am alone. 오케이.
시트에 어쨌든 들어와서 보고 같이 확인해 보는 게 좋으니까.
예.
그래서
잠깐만 이게
들어갈까요?
잠시만요. 이게 최신적으로
In the Arab states, there's many steel. They make many steel. Yeah.
했어.
Are the cable ends? Yes. He's your chief designer in electrical optimization, yes? I've seen Mr. Eom has learned a lot in the last months. Yeah?
대략 우선 수치는
Okay, yes,
This
have a
is-
controlling picture.
그러면
Two. Is here the transformer?
yes, transformer.
transformer connection 없네 지금.
Uh-huh. You see the transformer connection is small because there's a very, very short distance
Yeah.
to the transformer. Two flexible cables. This is one
possible.
tube,
Yes,
one tube,
yes.
and tubes on the electrode holder. The electrode holder is deeper, yes? This may be compatible. To this, with tubes on the electrode arms.
Yeah.
Here are 2 tubes and there's 1 tube, yeah? Okay.
저기 LF 지금 나온 동료입니다.
There's a big circle diameter there.
나온
And there's relative grade.
저거는 수정해야 돼요.
Yeah? The power is small, yeah? This can be smaller. The diameter. Yeah? Can be smaller.
한번 바꿔봐라.
이거 말씀해 주니까 이거 전체적으로 좀 다 바꿨는데 전기 공부
바꿔야지. 어차피
How many tons has the ladle furnace?
30.
30 tons.
How many class this barrel?
Yeah, this is not equal. This is, you see that?
Yeah.
Go on and see the top view of the total system. Yeah. You see, this electrode should in this position. Yeah.
Yeah.
일단 키워야 되네.
Yeah. This, you should make this a little bit longer. And you can also make these distances shorter. Yeah?
Yeah.
Therefore, this value is too high.
먼저 만들어서 코멘트를 주는 게 더 중요한 것 같거든?
예.
구조를.
예. 잠깐만, 그럼 어떻게 해야 되지?
줄여야지, 일단. 줄이고. 줄이는 거. 그냥.
Very high. Or ladle furnace. But the high reactance is only because you have 1 tube. This is small. This gives a high reactance.
우리가 아예 바꿔줘도 된다니까. 저기 원튜브로 만들어졌다고 해갖고 굳이 그렇게 갈 필요가 없어. 그치? 맞추고 조정해서 이게 그 가격적인 면이라든지 이런 걸 확인해보고 가야하는 거지. 일단 가격적인 면보다는 가장 효율성이 좋고 안정적인 구성안이 첫 번째잖아. 그렇게 하고 난 다음에 이게 적용이 되는지 안 되는지 여부를 이제 판단해 가야 되는 거니까. 지금도 높다. 일단 기본적으로 리턴스가 높다고 그러잖아 지금.
예.
줄일 수 있는 방법 먼저 구성을 만들어줘야지.
Well, this
First we reduced the
this
returns.
this value is too high. Yeah.
current transformation. 튜브 왜 저기도 한 개지?
하나로 길이 한 개로 돼 있어서.
그러니까 이제 그거를 그 부분은 좁잖아. 좁은 부분이고.
예.
물론 줄이는 거 저걸 두 개로 해도 어차피 두 개로 나올 것 같은데. 두 개로 해봐봐.
This now is better. Yeah, it's better. Oh, this is a little bit smaller.
Yeah.
This is not bad. We have left on the controlling picture, side view.
네.
어떤 높이가 다 틀리네.
But these are tubes on the electrode, mounted on the electrode arm.
Yeah.
But you can make this distance short, like here. Yeah, this distance should not be too great. Here, in the middle phase, the distance is higher.
Yeah.
And the electrode diameter is 300 millimeters or what? 200 millimeters.
예.
22 큰데, 22 큰데. 맞나? 그겠다, 22.
그렇죠.
This you must construct because these electrodes are not, the phase angle is not 120 degrees, it's 90 degrees.
지금 90은 아직 안 맞죠.
It's very fast in input data. You have also your computer at home and continue to give data in the evening? No. When I was young, I had my best ideas I have had in the middle of the night.
오케이.
20도. 근데
Yes.
Oh, this is very good.
7도.
Show
소리네.
the picture of the total system. This seems better.
120이 안 됐지 않나?
예, 안 되겠어.
그럼 안 맞는 거잖아, 지금.
This very is.
Yeah, this is
okay?
better.
This better?
It's better than before. Should,
Yeah, but
the standard size should be 120 degrees.
yeah.